Getting into the specifics now of the USC Approval Program. And with the USC Approval Program, the issues that we'd like to address today, we'll start from the standards for those assemblies, the approval program itself, then we'll comment about the list of approved assemblies and how that can be used and the information that you can find that'll help you in the field, and then other approval issues. And this is where we'll find that some of the problems many of you have seen with modifications or changes that are made in the field, how does that possibly affect the approval status of an assembly? So we'll be going through each of these subjects this morning and hopefully filling in some of the information you've been looking for. As we mentioned earlier, the USC Approval Program is fully detailed in the current Manual of Cross-Connection Control. Actually, Chapter 10 of the 10th edition is where you'll find the current standards. But understand that the standards didn't just materialize overnight. There was some early work that was done. In fact, with the very early work of the foundation when it was established back in 1944, one of the original objectives of the foundation was to go out in the field, find assemblies that were commonly used, and some people don't realize that there were a lot of different products in use back in the 1940s and before. So the foundation staff at that time went out to the field, performed field tests to determine how were these various types of backflow preventers that were fairly common in use at that time, how were they doing? How effective were they? The numbers that they have here is how they identified them, where they said the number one type of an assembly was a double check valve assembly, and number two was what was known as a superior pressure principle assembly. The number three was a reduced pressure principle assembly that we recognize today as the RP, as well as pressure vacuum breakers and non-pressure type, or what we might call atmospheric vacuum breakers. So their task was going around locating these and actually determining how they were operating in real-world conditions. And basically, their conclusions, some of easily mirror what we do today. The conclusions of the staff at that time said that double check valve assemblies, because of the nature of how they operate, because there was no external discharge or indication of operation, they felt that they were suitable for non-health hazard type applications, which is the same as what we see today. Interesting, the number two, the superior pressure principle type of product, was found to be probably not providing the type of protection that some thought. The superior pressure principle actually requires a back pressure to push back through the unit to make the relief port open. And this is where it was felt that under some conditions, if both checks were leaking and a back pressure was there, water could actually backflow through this type of product with the relief valve not ever opening. So this is where they felt the superior pressure principle was not providing the protection that a reduced pressure principle was. So this is where they found that the RPs that were in use were operating well, and they agreed that they're suitable for health hazards. In fact, some of the early conclusions, they felt they were equivalent to an air gap, but I think in our modern terminology, I don't think we would ever consider a mechanical device the same as an air gap. But at that time, the researchers felt that the RP was supplying a superior type of protection as compared to some of the other products. And with the vacuum breakers, they did agree that they were suitable for a specific application of back siphonage only. So this is where we found that this early work of the foundation is pretty much mirrored in many of our actions that we follow today. In fact, as we start looking at those original objectives, when they established the very first standards, this came out in 1948 in what was known as paper number 5. And I know we get a lot of people asking, well, what was paper number 1, 2, 3, 4? And to our understanding, these were just numbers assigned by the School of Engineering at USC, and there may have been papers on other subjects. This just happened to be the fifth one at that time. And in that paper number 5, there were standards for the double check, the RP, and the PVB. So with paper number 5, which was published, we found that there were products that could be evaluated, and some of the very early work of the foundation was evaluating those products against paper number 5 and products that did actually comply and gained an approval. Well, interesting though, with those original standards, what was involved with the evaluation process? Well, they felt that a laboratory evaluation was necessary. And they also felt, and which was unique at the time, that some type of an real online in-field evaluation was necessary. And the problem that kind of developed later on, this standard had a 2-tiered type of field evaluation. First, you'll see that they had to go through a 6-month field evaluation. Once they successfully completed the 6-month field test, they got provisional approval. Then additional products had to go out in the field for additional 3 years of field evaluation. And then at the conclusion of that 3-year evaluation, the products would then gain full approval. Well, the difficulty we found was people mixed up the word provisional and full. After a while, all people were ever looking at is, was the product approved or not? So we found that a lot of the early approved products on our list had specific notations about provisional or full approval. And this is where you'll see as we go through in our discussions of standards, this confusion was eliminated into a single field evaluation with the later standards. Paper number 5 and subsequent documents that the foundation produced finally culminated into the development of a recommended practice manual. So in 1960 is when the first manual of cross-connection control recommended practice, or that we commonly call the Blue Manual at the time, came out. And with this was not only the standard, but many of the recommended practices, talking about issues in the field, types of cross connections, things that would help, again, people active in the cross-connection control industry. Kind of a milestone that took place in one of the earlier manuals was input that was coming from the field. And this is where some thought that our manuals may have been developed by just a group of people not directly involved with field type applications or people operating programs, but we received a significant input from field personnel. So in the 4th edition of the manual back in 1969, one of the major changes was for the backflow preventers that they had to be inline repairable. Well, testers today may not recognize the issue that before that time, you may have had to take an assembly out of the pipeline to work on it. It was not a requirement in the earlier standards. And some may say, well, that's not a problem. Well, if we're talking about a small assembly that weighs, 15, 20 pounds, it may be removed without too much problem. But what about the larger 8 and 10-inch diameter assemblies that weighed 2,000 pounds? And you had to pull that out of line to work on it. So because of the issues that field personnel were providing back to the foundation, at that time the standard was changed so that all products would be inline repairable, which means all the internal components are accessible for maintenance or repair without having to take the entire body out of the line. So this was a major change that helped people in the field. And also at that time, you'll see that the field evaluation changed to a single 12-month field evaluation. Because of the problems that had been expressed about understanding the provisional or full approval, the foundation felt that a single 12-month field evaluation would satisfy this and, again, prove the product operated satisfactorily. It was also well received by the manufacturers. Instead of having a 3 or 3.5 year field evaluation process, a 1-year field evaluation was considered to be a much more acceptable practice and felt to be reasonable. So again, 1969 was a significant change, in our standards.